In this presentation, we will learn how to traverse a single linked list, and we will also see one application of traversing a single linked list, that is counting the number of nodes. So let's get started. First, we will try to understand what is the meaning of traversing a single linked list. Traversing a single linked list means visiting each node of a single linked list until the end node is reached, which means that you are visiting each node of a list until the end node is reached. For the sake of simplicity, we will consider this example. That is, we will assume that we already have this list and we need to traverse this list. Not only we need to traverse this list, we also have to calculate the total number of nodes in this list by traversing this linked list. Okay? So we will assume that we have this linked list already. The head pointer is pointing to the first node of the list, and our job is to calculate the total number of nodes in this list. For this purpose, I am writing this program. Here in this program, we should have these two header files, stdio.h and stdlib.h. We should have this struct node as well. And apart from this main function, which is the starting point of the program, and here we are basically calling this count of nodes function, which will count the number of nodes in the list. And here I'm passing this head pointer, which I haven't declared over here. So what is this head basically? This head is the pointer which is pointing to the first node of the list. We need to imagine that head is the pointer, which is the pointer to the first node of the linked list shown here. I'm not writing the complete code over here. Okay, you already know how to create a single linked list. The first job is obviously to create a single linked list like this, and then after that we will call this count of nodes function, and here we need to pass this head pointer. This pointer is enough because this is pointing to the first node of the list, and we already know with the help of head pointer we can actually reach every node of the list. So we need to pass the head pointer of this list to this count of nodes function. But you should always remember that we first have to create this single linked list. Then after that we can call this count of nodes function. I'm calling this directly because I'm assuming that this single linked list I've already created and there is no need to create this again. So this is not a complete code, by the way. Okay? Because our focus is to understand count of nodes function and nothing else. Now here is the function which consists of these line of code. Now let's try to understand this particular piece of code properly. Here we are declaring this count variable which consists of this value 0. This is the initial point. Count contains 0. Okay, basically this variable is used to count the number of nodes in the list. That is why I call this variable count. After this we have this piece of code which says that if head is equal to null, then we will print linked list is empty. Head is the pointer which is pointing to the first node of the list, right? If head contains null, that means it is not pointing to anything, and this simply means that linked list is empty. That is why we have to print linked list is empty. If this is not satisfied, as you can see over here, this is not satisfied. Head must contain the address of the first node of the list because our list is not empty. So definitely we will reach this point of code. That is, we will create a pointer of type struct node and we will initialize it to null. After that, we will put the value of head inside this PTR. That means we know that head contains 1000, so this null will also get replaced by 1000. This is what this line says. Because of this, PTR will point to the first node of the list. After that, we have this piece of code which will run until PTR becomes null. This is the while loop which will run until PTR becomes null. Right now, PTR contains the address 1000, which is the address of the first node of the list. When PTR contains null, then we get outside of this loop and we'll print the count. Let's see how this code works and how it is helping us to traverse the list. First, of course, we need to check this particular piece of code that here PTR should not be equal to null. We know that PTR contains the address 1000 and it is not equal to null. Therefore, we can get inside this while loop and we'll increment the value of count. This means that the 0 will get replaced by 1. And this simply means that the first node has been visited. This count variable is keeping the count of the number of nodes, right? This one indicates that first node has been reached. After that, with the help of PTR, I am accessing the link part of this node, which means that this can be replaced by 2000 and eventually PTR will contain this address 2000. This means that now PTR has been assigned with this address 2000, which eventually says that this PTR will now point to the second node of the list because it contained the address 2000. After that, we will again check, is PTR equal to null? No, PTR is still not equal to null, right? We'll get inside this while loop, we'll increment the count, which means that now the second node has been reached. And you can clearly see that PTR has reached the second node. So it is clear from this fact that second node has been reached. After that, we will again implement this statement, PTR equals to PTR pointer link. We know that PTR link gives the link part of this node, which means now this can be replaced by 3000 and eventually PTR contains the address 3000 after this line of code. Now it will point to the third node of the list. After that, we'll again check this condition. Is ptr equal to null? Still it is not equal to null. We get inside, increment the count. Now 2 can be replaced by 3. And then after that, we'll access the ptr link. That is, we'll access the link part of this node which contains null. So this can be replaced by null, and now ptr contains null. Again we will check this condition. Is ptr equal to null? Yes, ptr is equal to null. So we'll get outside of this loop, right? Because here this condition becomes false. ptr not equal to null is actually false because ptr contains null. Therefore we'll get outside of this loop and we will print the count, that is 3. So output is 3. Although, let me tell you that there is another way of writing this code. Instead of writing this whole code, I can replace this with another code which we will see in the next lecture. Okay friends, this is it for now. Thank you for watching this presentation.